Hi everyone, fluid mechanics. In this example, we are working around a body of water in a reservoir, and there is a gate which is hinged at A, and then it's held with a cable and attached to a vertical wall. If we know the dimensions, for example, the length of the gate and the amount of water filled in tilted direction it's about 6 feet of water, and the angle of tilted gate to the horizon is 60 degrees. And also, if we know the weight of our gate is 800 pounds, and the dimensions are also provided, like 8 feet in length and 4 feet in width, we want to know what would be the tensile force inside the cable with these with this information provided. Let's start the problem. So first thing to do, we need to calculate the resultant force of water to the gate. Mhm. And the location of the resultant force, we do know that's the center of pressure from previous uh, examples. So first we want to calculate the resultant force, and resultant force is nothing but a gamma h bar center times the area. Area is definitely a rectangle, which is 4 feet in width and also 6 feet in height, because we are just interested to the amount of to the length of the gate which is filled with the water. So that's our area. So FR is a 62.4 times. So if this is the case, a half of this length to the centroid is, if this is like 6 feet in a hypotenuse, this is 6 sine of 60, and half of that would be a 3 sine of 60. So that's h bar c, and this is our area. So if you calculate the F sub r, or resultant force, that's a 3890.88 pounds. So that's our resultant force. Then definitely we do know the location of the resultant force. It's not the center, but center of pressure. So, and how to calculate the center of pressure? Y Cp, Y component of center of pressure is equal to Y sub C, Y component of centroid plus IXC over YC times area. So YC is almost already 3 meters from the top, 3 feet from the top, and IXC for a rectangular plate is a 1/12 base cube height, and that's 1/12 4 times 6 cube over YC times the area. If you add it up, it just gives you YCP is equal to a 3, and this term is just turned to be 1 feet. So YCP is equal to 4 feet. Then by just developing a moment about point A, because this is hinge over here, if we just create a moment about our hinge, so we can have summation of moment about A equal to 0, then resultant force at X, if we just consider it like X, the distance to the hinge. So this length is already 4 feet, so our X is 2 feet. We already calculated that, then times uh, minus F resultant force times X minus a W cosine of 60 times 4. So we are talking about this component of of because the other one is just passes through the, if you just shift this component to here, it just passes through point A and doesn't create any moment. So W cosine 60 times a 4 feet, it just creates the moment for W, for weight. The weight comp That's the moment for the weight component. Then plus T times 8 times sine 60 degrees. That's equal to 0. And if you do so, it just gives you FR. We already calculate that part. And times 2, which is this distance. W cosine 60, we already talked about that. 4 is centroid, is the center of mass applies to the whole length of gate, not only filled with water. So we need to consider the whole length for weight of the gate alone, and that's a half of that, that's 4. That's why we just use that one here. Then if you replace the numeric value, it just gives you a tensile force inside the cable is 1353.79 pounds. And it was an interesting problem. The important note for this problem is after creating a clear-cut free body of diagrams, then the starting point is where the water surface stands. So we need to calculate everything based off water surface elevation and create our y-axis at the base of water level. But for the weight component, we need to consider the whole length of the gate. Thank you. We'll solve more problems.